So here I am introducing a new product that is known as RMGX. It is known as Grignard reagent. It is identified by the scientist Victor Grignard. So after him it is named as Grignard reagent. If we check this compound here, you can see a direct metallic bond of carbon with the metal. So this compound is known as a organometallic compound, and there is a halogen also there. And this compound here, if you check this compound, you can see so many products we can form if we react this compound with a suitable reactant. We can form so many compounds from this compound. It is a very good starting material for so many reactions. So why Grignard reagent is so reactive? Why it is react with uh, aldehydes, ketones, carboxylic acids and alcohol? If we start the reaction with this Grignard reagent or any other carboxylic group, if it is a nucleophile or electrophile, anything, why this Grignard reagent is so reactive? Grignard reagent is also reactive like you people. Why it is so reactive? Because the reason is, we know it is an alkyl group and is a magnesium. This alkyl group is high electronegative than this magnesium. So what will happen is the shared pair electron will move towards this alkyl. So it will carry negative charge. So this alkyl group in this Grignard reagent is a carboanion. The carbon is carrying negative charge in this reaction. So there is a covalent bond between this magnesium and carbon or alkyl group. And if you check with this magnesium and halogen, there is an ionic bond. So there is a negative charge on alkyl group, a positive charge on magnesium, again a negative charge on our halogen. So this compound is highly reactive. This MgX part of this compound will easily remove in a reaction. So this MgX part will remove and other group will attach to this. If the MgX group it will leave, this CHO is attached to here, we will get the compound according to that. Similarly, we'll get so many compounds. So let's see how this Grignard reagent is preparing, or what is this Grignard reagent. Why it is important in our haloalkane. So if a haloalkane is directly treated with a metal in the presence of dry ether, we'll get alkyl magnesium halide, that is Grignard reagent. So it is a direct addition of metal. If you check for example, if you can see here ethyl bromide. Ethyl bromide is treated with magnesium in the presence of dry ether. Dry ether is a solution there, solvent is there. So we'll get CH3, CH2, MgBr. So we can see the reaction. Not only magnesium, so many active metals can directly attach with our haloalkanes. So we can see some other reactions. Here we can see the lithium attached to here, and this bromine, and this there are two lithium here. So one lithium attached with the bromine. So it is a elimination also occurring here. So it is a elimination reaction or substitution reaction, both will occur. Similarly, if you check here, zinc also an active metal. Here you can see the product zinc also attached to this compound. Here the zinc Br is there. Similarly, we will get different compounds. If metal directly attached to haloalkane, will get different compounds. Okay. So many compounds are there, so many Grignard reagents are there, but the important Grignard reagent is CH3MgBr. It is known as Grignard reagent. So many organometallic compound is there, but our Grignard reagent is very important. And how this Grignard reagent is useful in the preparation of alkanes. It is a very important reaction. This reaction is known as Wood's reaction. I hope you already studied this in your +1, but it is a very important reaction, that's why I am repeating again. So very important reaction of the Grignard reagent is the Wood's reaction. So the starting material is our haloalkane. So first step is the formation of Grignard reagent, And the second step is the formation of the alkane. Here you can see the example equation. There are two haloalkanes. It's reacted with two sodium. First, it is the reaction. There is formation of the magnesium halide and alkane. For example, if we are treating methyl iodide with sodium in the presence of dry ether, so in the presence of dry ether, we can see that this methyl group will the formation of the alkane, and the sodium and iodine together will give 2 sodium iodide, and it is a very good reaction for the preparation of higher alkynes. For example, ethane, propane, higher alkynes from than methane. So it is very important reaction in chemistry. So we'll see the mechanism of the Wood's reaction. The first step is the formation of the organometallic compound. Here instead of magnesium we are using sodium. So what is the reaction is, the first step is, here there are 2 sodium. So first step is this one sodium is directly attached to this, and first Br will leave. The first step is, very first step is Br will leave. So there is a formation of carbocation here, carboanion here, CH3, CH2, CH2 minus will be formed here. So this sodium will attach here, sodium carrying plus charge, so it will attract here. So we get the first compound, that is a organometallic compound, because it is contain carbon and metal bond. We'll get sodium bromide. The second step is SN2 reaction. So you know SN2 reaction. What will happen is, in SN2, this is a nucleophile. So it will attach on this. So Br will leave, our halogen will leave, and this nucleophile attach here. So it is the reaction, and we'll get this part of alkane is attached to here. This bromine will leave, and bromine and sodium also leaves. So we'll get NaBr. This is the step of the Wood's reaction. So we completed the chemical reactions of haloalkanes and haloarenes. We studied about substitution reaction, elimination reaction, and reaction with the metals. So these are very important. And one more thing, in elimination reaction, it is also similar to the substitution reaction. There are E1 and E2. It is almost similar to SN1 and SN2, and we can compare those things. Okay.